So if we think about the reaction force of the sine, this is a little bit different now because, we have the sine that, you got a force coming down like this, but then you have this, kind of force coming up like this that we're looking at. And so in this one, and then, something's happening down here, right? And so we have to consider all of those things. Let's say that we have a beam that's being held here, and this part right here is free to move. This is a line of tension holding this beam up. So if this snaps, this is just going to fall down like this. Let's say the mass of the beam is 150 kilograms, and we want to find out what the tension force is here, how much force of tension there is, and then also what's happening over here, because there's a wall over here, and then this is this is going to certain amount of force is going to be felt over here. So again, the hinge is free to rotate. If it's not, then this wouldn't be, the value that we're going to get over here wouldn't be the same as if it wasn't free to rotate. We have the force of gravity of the beam there. We have the force of tension over here. And we have some sort of, wall force, reaction force, we're going to call it over here. And that's part of what we're going to find out. We want to know what tension is. We want to know what the reaction force is. And we actually don't know either. So we're going to use, what we can do here with the forces and the torque to figure out what's going on. So we're going to break down the reaction force and the tension force into the x and y so we can get it in something that we can use. And we'll set up the sum of the force in the x, sum of the force in the y, sum of the torques. The forces in the x, positive force of reaction in the x plus the negative force of tension in the x. In the y direction, positive force of reaction in the y plus the positive force of tension in the y plus the negative force of gravity. And then for your torques, we're going to use the rotation point as right here is the hinge. We could technically have used, this over here and then use that as a rotation point, but it's a little bit more intuitive to use the left-hand side. And so in terms of setting up the torque, right, we have force of tension in the y, which is over here. And if we break up the force of tension is located right here, right? We're just breaking in the x and y components. So that y tension is right here. So we've got that. And we have the force of gravity. So we can actually solve for what force of tension the y is. We'll, 1/2 x is how far the force of gravity is of the beam. We can cancel x from both sides. So the force of tension the y comes out as 1,470 newtons. Now, if you notice here, this angle, theta, is 30 degrees. So because we know that, we can figure out what the overall force of tension is. We have, this is right here, force 1,470, and we know the angle, so we can use trig to find the hypotenuse, which is the force of tension. And we can set that up with, oh, that's right. No, I'm sorry. We are, if you put this in terms of force of tension as the sine of 30, we actually already did that. So that is the force of tension. Sorry about that. So the force of tension here is, what we found. If you just left this in FTY and then solved for it, you would have gotten a different value. And this has the trig already in it. So I figured I did that. And that's usually how you'll set it up. Once you find that force of tension, to get the FTX here, right, you have the hypotenuse, which is 1470, and you're looking for the FTX, which is the cosine equals adjacent over the hypotenuse, so the cosine of 30 equals the adjacent side over 1470 cross multiply, so we got that, right? And so the reaction force in the x is 1,273.1. And now that we know that, we can look at what's going on in the y direction. We know what FRX is, and force of tension in the y we're going to place in here, which is the hypotenuse times the sine of 30. And we can figure out the force reaction in the y. So now that we know the reaction force in the x and y, we can use the Pythagorean theorem, set up our coordinate axis, 1273.1 newtons in the x, and then 735 in the y. Opposite over adjacent to get the angle 30 degrees north of east, 1470. And this will be true as long as there's nothing on the beam. It'll actually be the same, and that should make sense because the tension is has to be completely canceled out by the other side so that the equilibrium is reached there.